Okay, this is lesson 7.2 notes. On lesson 7.2, we're going to be finding the areas between two curves, but sometimes we're going to slice the curve vertically, like this. Sometimes we're going to slice the area horizontally. So I want to try to explain the difference because depending on which way, some problems you can do either way, some problems are best done one way or the other. So you kind of have to think about what's easiest. If I drew my rectangles vertically on this first diagram, like this, for example, here's one rectangle, then the skinny dimension, or the smallest dimension, runs sideways, which is a change in x. So we would say that this dimension right here, we would call that dx. That would be the width of our rectangle. Let's say the top function is f of x. Some function, some equation, we'll call it f of x. Let's say the bottom function down here is called g of x. So how do you think I would find the height of that rectangle from here to here? Any ideas?
Point at d or the take.
F of x minus g of x.
Yeah, you just take your top. F of x is this. F of x is this total height. Here, this is f of x.
Oh.
G of x is this total height. Because if you take this height of f of x minus g of x, you get the difference, f of x minus g of x. So what we want to do though is get the area. Actually, we want to find the area of this rectangle. So to get that, we're going to take length times width, right? So we're going to take the height, or height times width, f of x minus g of x. That'll be the height of our rectangle. Take that all times d of x, the width of the rectangle, and that would give us the area of the rectangle. Okay, so this is your height of the rectangle. This is your width of the rectangle. But now we don't want just the area of that one rectangle. We want to have lots of these little, whoops, I didn't draw that very good, lots of little skinny rectangles in here that fill up this space. And we're going to keep slicing it vertically, like that. We want to add all those up. So what symbol do we use to add things up in calculus? Well, sigma is the Greek letter, but the Roman letter is that. Okay. That's the skinny s. That takes, if your statistics use the Greek letter sigma, it looks like this. Okay? But in calculus, we normally don't. Sometimes we do use that also. But right now, we're using the integral symbol, the Roman symbol, which means the same thing. So that is going to give us the area between those two curves. All right? Now, notice this. If I would have tried to run the rectangle sideways, let me put one in black. If I would have tried to run the rectangle like from here to here, I would have problems figuring out how long that is, that dimension right there. Because what curve is on the right and what curve is on the left? F of x is on the left and the right. So it'd be like taking the curve minus itself, which would give you 0, so you really wouldn't get a true answer there. So on this problem, you really have to run the rectangles vertically to get this to work out right. Now a problem like this over here, we can run the rectangles horizontally. And again, let's just call this f of x. Let's call this right curve g of x. So if I want to find the difference between here and here, so this distance here is g of x, this distance here is f of x. So how would I find that distance between them?
G of x minus.
Yeah, let me give you a number. Let's say this is 5, and let's say this is 3. So this is 5, this is 3. What do you do with those two numbers?
Okay.
Subtract them, right? You take your bigger number minus your smaller number, and that would give you a distance of 2 here. Okay? But we're not using numbers because depending on where you draw your rectangle, those numbers would be different, wouldn't they?
Yes.
They would vary. These x-coordinates are going to vary depending on where you draw your rectangle at. So we have to use variables because depending on where you're looking on the curve, you're going to have different values, different x-coordinates here. So we really have, the way I'm drawing is this is g of x. Actually, I'm saying that wrong. That should be g of y. everything in terms of y. I'll explain here in a minute. This would be f of y. So the distance, let me erase some of these. So what do you think this distance would be right here?
G of y minus f of y.
G of y minus f of y. Yep. You have the right curve minus the left curve. And what do you think we'd call this skinny dimension now that it runs up and down?
dy.
dy. Good. So I think when you draw your rectangle on your picture, think about where the skinny dimension, if it runs sideways, you're going to use dx, which means everything's going to be in terms of x. If the skinny dimension runs vertically, then you're going to use dy, which means everything's going to be in terms of y. So now your area is you're going to take this dimension of the rectangle times this dimension of the rectangle, so you're going to have g of y minus f of y all times dy. That will give you the area of that particular rectangle. Then if you want to add up the area of all the rectangles, you do the integral. So here we're doing right curve minus left curve. Whenever you slice it horizontally, do right curve minus left curve. You'll have equations in here, and they have to be in terms of y's, so the equations have to have y's in them. When you're slicing vertically, then you're going to do top curve minus bottom curve. And they don't have to be curves, they could be straight lines too, but
Oh, this will actually know the equations.
okay? Then everything's going to be in terms of x. Now, the last thing, the bounds. Well, your A is always where you start slicing. So, like right here, I'm going to start slicing right here. This would be my A. So my A is going to be an x coordinate. It's going to be a value of x. And everything in here is going to be x's. I'm going to stop slicing right there. My B would also be an x coordinate. So just make sure that when you put in your A and your B, you're going to look at where these two functions intersect by using a graphing calculator or maybe solving it analytically. But you're going to use the x coordinates here if you have x's in your function. If everything's in terms of x, make sure these are in terms of x. Here, you'd start slicing at the bottom. Start slicing it this way into rectangles. So you'd start here and you'd stop here. So you're still going to have A and B, but this time your A and B, if your functions are in terms of y, then you better make sure your bounds are also y coordinates, not x coordinates. Any questions about that?